Hello everyone, welcome back. We are going to be talking about transformations with the sine and cosine curve. So we're going to be talking about displacement, that's a shift up or down. And how's the function been moved up or down? For example, and these are all universal truths when we come to any kind of function, f of x is going to be equal to the sine of x, let's say plus a. That would be a shift up a units. If f of x is equal to the cosine of x minus b, that would be a shift down b units, right? So we're going to be moving these functions left and right by making changes to the graph, to the equation of the original of the parent function. So if we look at example A, I'll do this in red. What I'm looking at is I'm identifying a sine curve that has been moved down 2 units, right? The y-intercept now is -2, whereas the original sine curve looks like this. And if you need to just do a little sketch of the original sine or original cosine functions, go for it. And then it'll help you see how the transformation happened. Okay, in B, what I'm looking at now appears to be what I see as a cosine function, but I'll just sketch the parent function of cosine just to make sure. In fact, that's exactly what it is, and it's been moved up 1, 2, 3 units. So I'm looking at the I am looking at the cosine function, cosine x plus 3. Okay, now in the next one, you could make a case in a lot of different ways, but what I'm going to suggest is that you just keep it as simple as possible, and we're bound to see the same situation in a couple of different ways. And as long as you're accurate, then I'll accept, the range of answers that are possible. But you're going to see me keep it pretty simple here. I'm going to graph, I think, to me, this looks like a cosine curve that's been reflected and stretched. So I'm going to just sketch the cosine function. Right? And what I see is the cosine function that's been flipped over. So there's the reflection, right? It's been reflected and stretched by a factor of 2. But I also see that it appears to have moved as well. So we might have to do a little bit more work with this one. Let's see. If it was just -2 cosine x, then this is what it would look like, right? But it appears to also have been stretched. So let's see. If we can't get it with cosine, maybe we've got it with sine. Let's see if maybe it was the sine function moved over a little bit. So erase my points. If you see, and I'm working my way through this too, perhaps what we see here is a sine function as well, right? That's been reflected or moved in some way. So, and this is where it can get a little bit tricky and can be left kind of up to the observer, and where there could be more than one answer. Okay, now what I'm seeing is a basic sine curve, right? That's been, so the sine of x, that's been stretched by a factor of 2, moved up 1. So I'm looking at a vertical stretch times 2. It's been moved up 1, and then it appears that it's been shifted. If this is pi over 2, this is pi, this is 3 pi over 2, this is 2 pi, it appears that it's shifted, -3 pi over 2 units. Right? And again, if you see a cosine curve that's been modified in some way, I'm absolutely open to interpretation. We'll go slow and take our time with these and do a lot of examples, but I just wanted to show you how to look at the sine and cosine curves with some sort of transformations made. More to come in the next video.